Alright, we are live. Okay, I procrastinated for 15 minutes before going live, but finally clicked the button, which is better than procrastinating a few hours before going live like yesterday. So we're happy about that. Today, yeah, we've been reading a lot on how we do performance tuning, how we profile, but really the best way to learn is just by actually doing. So I asked chat to generate a program that we can try optimizing, just as an exercise. And we can figure out to do this exercise. Actually, the code is already here. First, sorry. This is the thing. Sometimes I have thoughts and I jump to the other thought, and then I don't finish the sentence before, and then it just sounds like I'm all over the place. So the sentence I was going to finish before is the most important thing is to practice. Now, before we actually get into practice, we want to be familiar with the profiler, the PyTorch profiler, and how do we actually use it. So we're going to quickly use this tutorial for learning the syntax of how to use the profiler. So the profiler is imported by doing from torch.profiler import profile proportion and profiler activity. Okay, I don't know why profile activity is needed. Okay, and then we can instantiate a resonant model. Why is it no rough formatter? Okay, I guess there is. Okay, and then we can run okay, let's do this. Okay, so it runs, but now we actually want to analyze the execution time from running model on inputs, right? Alright, so what we would do is our profile I see. There's another I'm trying to find the docs on the tuning guide. No, that's not the tuning guide. But I remember reading on the performance tuning, and we were somewhere it was saying to do record shapes. But is it here? That's the same as this, right? Okay. Okay, so when they profile, okay, so this was what I was looking at, and then so now I can just refer to my live stream to see what I was doing. Wow, I already have 10 views. That's insane. Okay. This was tuning guide. I remember reading somewhere in the profiler. Was it? Where did it talk about CUDA graphs? CUDA semantics. Can you explain to me, like in PyTorch, like when you create, I swear I saw record shape somewhere. I just don't remember where I saw record
external
shapes
device
mentioned. I definitely saw it somewhere. Like, is it actually just here? Like, it might just be here. Yeah, I'm gonna write some notes here. Okay. Alright, so we're using this. We're just profiling it. Activities. So if we do this profiler, okay, afterwards we need to print the key averages dot table, and it's gonna tell us you can't do this because profile is undefined like that, right? So doesn't prof go out of scope here? Am I tripping? Like, do I not understand Python? Usually we do with open SF. That's like the only use of with that I'm familiar with. I see. I see. So the profiler stops recording when we exit it. That's interesting. I didn't know that. Okay. Alright, so in our case, we have, let's print out this table, and what we can see is what each of these operations takes. So cell.cpu percentage is just saying, for this operation alone, not accounting its child operation. So we can see that mkDNN convolution is taking the most time. These are all CPU operations because we're not doing anything on the GPU side. Like I guess we could .gp.cuda, but we're not doing anything on the GPU side. But if we did what is it, torch dot? Torch.cuda. Goes CUDA operation. Why is there no CUDA operation detected? Even though everything is on the CUDA side. Group by input chips. I see, so it makes it more readable. Oh, it's do I need to do this? Sorry, I forgot the syntax. No, that doesn't do anything. Am I tripping? What is torch is available? What is the syntax? Yeah, torch CUDA is available. This model is on GPU and this input is on GPU. And we're profiling this. So what is the issue? Like, do I need a record function? Right, but then that's not why. No, that's not why. Yeah, let me just copy paste this and see if their program works. It's only CPU. Oh, you can also, I'll put a trace. Alright, so I don't know why we can't see it, but it's kind of annoying. Let's try this. We can get a trace. And then Okay. Load. And download this. Okay, there's nothing that happened. Alright, cool. Hmm. Interesting. Okay. So you can schedule this. So when you're training your model and you're iterating to your data loader, training through multiple batches, you can you have this convenient feature that allows you to schedule when you want to actually run your profiler, because you might not want to run it at every time step and it will be hard to debug. So in our case, probably you want to just skip the first 100 and then say active as 1 and then repeat as 0. Okay, so we understand how this profiler works, but it doesn't seem to be that useful yet for us. Right, like, okay, we can just use this profiler and then we can print the profiler by doing prof dot, I already forgot the syntax. Prof dot key averages dot table. And you can do record shapes and profile memory. Okay. Alright. So now we're gonna take this program and try to optimize it using the learnings that we've had. So I guess the first thing we want to profile is how long each operation takes. Oh, so they already gave us a profiler. Maybe let's look at the video. Like, are you supposed to just
hardware and balancing the 100% utilization. 100% utilization means that you're leaving no performance on the table as per the right. And what that does is that it makes trace a lot easier to understand. So when we're in a particular section at the bottom, attribute, this is
so that you can make sure that you have a working training loop. You can see the breakdown of your model performance, provides an end. And we'll kind of get into, went through, we're not looking at a single processor into GPU, based GPU, capture see it took involved in running a model, and that provides speed up there. But really, model, and that provides speed. We're actually going to pivot to training ImageNet on, and this is causing an increase in the memory usage. So if we're operating with a really tight window with our CUDA memory usage, this might be enough to push us into a CUDA out of memory area. Let's talk about our final tool. This is holistic. The traces include our, you can see I ran this on Narval, and it gives us just stats for how long.
What is this?
Threaded run, and that's information between, say, your actor critics,
Oh, this is freaking useless. I'm trying to figure out what is the sort of like standard way to initialize your profiler. Okay, let me just ask chat. I'm trying to learn how the profiler gets used in like production systems, right? So like the tutorial shows the profiler just like using the profiler right before the function call, like instantiating it. But in a production system, you usually have some sort of data loader that you're iterating through. Do you sort of like do prof that start and prof that stop yourself, or you wrap everything in a with? Yeah, okay. Having a profiler is always too expensive. So they have this prof that step. Like the profiler will give us information on within our operation. Okay, are we printing? Do we have TensorBoard? Okay, so we have this run. Let's look at the data set, 50,000 image size, 1,000 different classes. Our get item here, this is going to create an image in CPU, but it's pageable because we're not using any sort of like specific CUDA malloc host. So afterwards, I assume when we're going to copy this into memory, it's going to have to pin it first. It's going to copy it into CPU and then transfer it into GPU. So ideally, if we can directly get rid of this overhead, that could bring us some. So make this pin memory. So we want to try to make this in pin memory first, and then our CNN architecture is fine. And then when we train, we have our data set, our data loader, we should always pin memory if possible, and then have multiple workers. And our model is fine, our optimizer is fine. We should torch.compile it, which automatically fuses the kernels. And we have a grad scaler, which automatically lowers the precision. Okay, I need to understand how the grad scaler works. This is complicated. Oh my god. Like, is there any optimization even needed? Like, we just do like Python profile background. Click on apply, and we profile it. What? Dude. How do we use the profiler? Okay, so this is useless. Why is this not printing? I'm being really stupid right now. Yeah, I think my CUDA profile is not working. What? Dude, what's going on? Like, this is a model that exists in GPU. No, what? Dude, you're copying the wrong code, though. Also, yeah, talking while thinking is really, really hard. Oh, what's going on? Come on. So number one is, okay, this profiler is stupid, and like, okay, I don't know how to freaking use a profiler. Where do you put this profiler? Okay, we instantiate a profiler, and then for each step, we don't stop it. So at the end of every step, we do prof that step, because it already starts profiling. And at the end of every step, it's gonna update its count, so it's gonna know if it should actually measure or not measure. And then at the end, we can export the stack trace. Like, you didn't write it. Oh, I guess here on trace ready. Okay. TensorBoard trace. I don't think that's why, man. It's all CPU time. Oh, look, like it ran on CPU, bruv. Sometimes like this GPT is freaking stupid, man. Like you're saying that dead giveaway. Oh, it's. Did you see Kudian? Right. So why is it CPU operation? Okay, so it is warning on CUDA, but if you do profiler activity CUDA, it doesn't capture properly. Yeah, so it's CPU. Okay, the other thing is, the very first thing when I'm trying to debug a program is I'm trying to figure out if it's like memory bound or compute bound. That is, like, is our data loader very slow, or is our compute happening much faster, or is it some like bandwidth problem when we're transferring data? However, when we're using the PyTorch profiler, I guess you can kind of see it by looking at which operation is taking the most, whether it is a convolution or like a copy, right? Is that sort of how you debug it? In our case, okay, is that sort of how you look at it? You should be able to see like copy from CPU to GPU, right? Through the profiler. Is that sort of how it works? Right. So in our profile playground, when we profile, like, why is it not printing anything, man? If you do warm up 10, then like, huh? Oh, why am I so tired? Come on. If you tell. I'm trying to understand why when I do warm up equals 1, where does warm up equals 2? It only records. See how it doesn't print it out, but if you warm up for 10 it does. But since the first step, it should already run it. So I don't understand why. I don't understand why if I do warm up equals 2 or 1, like the profiler barely prints anything, but if I do warm up steps 10, it does print something, even though it runs for the same, like if it runs for one step, right? So I don't understand why after warm up step 10, I suddenly see like so much more, because like at every step, you should already do one forward pass. And then we're doing a back prop. Loop buffer replies. Okay, maybe I'm misunderstanding how the profiler.schedule works. Yeah, like this is a 100, but like 20 is enough. But if you do warm up is equal to 10, what the hell? Oh, is it because it's not a nice ratio, so then it gets discarded? What the hell is going on? So how come 10? This is so weird. Oh, repeat. 0 means it will execute as long as the cycle runs. So then afterwards, time step. So when you're warming up, there's nothing that's measured, and then 3 is when it gets measured. Let's see, repeat means it runs forever. Okay, I'm being stupid. So if it's 6, so in theory 3 should be 3 should be the sweet spot where you actually measure it, no? Why is it 4? This is so annoying. I just want to freaking optimize this. It's so annoying. So what I've pinpointed is just like persistent memory. Alright, so let's going back to this exercise. I've really struggled with this exercise, which is good, which means that we're improving, which means that we have so much to learn. I don't like this GPT generated code because it just literally gave me all this stuff. But I guess it's like a nice blueprint. Hmm. So let's say we wanted to make this faster. Then when we initialize it, we can just do a torch. Right, and then wait, image flip. What the hell is going on? Hmm. Can I do -1? I don't know why you need a topo though. Okay, so this makes it much faster because we're directly creating the image in GPU. And if we're now also try workers equals 4. Cannot initialize. Random normal is Gaussian, right? I see. Okay. But if you have multiple workers, this doesn't work. Like, this is kind of hard, actually. I still don't know how to use this profiler correctly. Like, as a first step, okay, let's say I want to optimize the program. The first thing I look at is, like, is our data loader already using multiple workers? Usually your code base, like, people aren't stupid enough to not only use one worker, they're gonna have multiple workers already. So then, at that point, like, how can we figure out what the bottleneck is, right? Like, your profiler, like, can your profiler show that loading the data is slower? Like, I would just basically want to see, like, the steps of loading data versus computing, but then I don't know where the bottleneck. Can our profiler show that? Okay, I'm gonna end the stream here. This is really annoying. I feel like I haven't made as much progress. Like, it's not very straightforward. And there's